The sun. It's a giant ball of burning gas that gives us light and warmth. This massive star, located at the center of our solar system, is essential for life on Earth. Without its energy, our planet would be a frozen wasteland, incapable of supporting the diverse ecosystems we see today. But the sun is not always calm. Its surface is a roiling sea of plasma, constantly in motion, with magnetic fields twisting and tangling. These magnetic fields can snap and reconnect, releasing vast amounts of energy. It can unleash powerful bursts of energy. These solar flares and coronal mass ejections can send billions of tons of solar material hurtling through space at incredible speeds. These explosions are a reminder of the immense forces at play in our universe. They can light up the night sky with stunning auroras, but they also pose significant risks. We depend on the sun, but we must also understand its potential for disruption. Solar energy powers our homes and devices, but solar storms can disrupt this delicate balance. These solar explosions are not just interesting events for scientists. They are critical phenomena that require close monitoring and study to predict their impacts. They have the potential to impact us here on Earth. Solar storms can interfere with satellite communications, GPS systems, and even power grids. Our technology-dependent world is surprisingly vulnerable to these solar storms. A major solar event could cause widespread disruptions, affecting everything from air travel to financial systems. Understanding this threat is the first step in protecting ourselves. By studying the sun and its behavior, scientists hope to develop better ways to predict and mitigate the effects of solar storms, ensuring that our modern world remains resilient in the face of these cosmic challenges. Solar flares and coronal mass ejections, or CMEs, are the two main types of solar explosions. These powerful events originate from the sun's outer atmosphere, known as the corona, and can have far-reaching effects across the solar system. Solar flares are intense bursts of radiation. They occur when magnetic energy that has built up in the solar atmosphere is suddenly released. This energy travels at the speed of light, reaching Earth in just over 8 minutes. Imagine the energy of billions of atomic bombs exploding at once. This comparison helps us grasp the immense power contained in a single solar flare. That's the power of a solar flare. These flares can cause radio blackouts and affect communication systems on Earth. CMEs, on the other hand, are massive eruptions of solar material. They involve the ejection of plasma and magnetic fields from the sun's corona into space. They hurl billions of tons of charged particles into space at incredible speeds. These particles can take 1 to 3 days to reach Earth, depending on their velocity. Both flares and CMEs can disrupt our planet's magnetic field. This disruption can lead to stunning auroras, but also cause geomagnetic storms. They pose a significant threat to our technology-dependent society. Satellites, power grids, and communication networks are particularly vulnerable to these solar events. Understanding these phenomena is crucial for developing effective mitigation strategies. Scientists and researchers continuously monitor solar activity to predict and prepare for these potentially disruptive events. Earth has a protective magnetic field surrounding our planet. It acts as a shield against the constant stream of charged particles from the sun, known as the solar wind. However, during intense solar flares, or CMEs, this shield can be overwhelmed. When the Earth's magnetic field is disrupted, it can induce powerful electrical currents in our planet's infrastructure. This disruption can have cascading effects on power grids, communication systems, and other critical technologies. Satellites are essential to our modern world. They provide communication, navigation, and Earth observation data. However, their exposed position in space makes them highly vulnerable to solar storms. The intense radiation and charged particles from these events can damage sensitive electronic components. The loss or disruption of satellites could have severe consequences, including communication outages, GPS errors, and disruptions to financial transactions. Protecting these assets is paramount in a technologically reliant world. Section 5, IAEA Power Grids Down, the risk of technological blackout. Our power grids are the arteries of our modern world. They distribute electricity that powers our homes, businesses, and essential services. However, these grids are vulnerable to geomagnetic disturbances caused by solar storms. The induced currents can overload transformers and cause widespread blackouts. Imagine a world without electricity, no lights, no refrigeration, no internet, no hospitals. The potential for economic disruption and societal chaos is immense. We must invest in grid resilience to mitigate this threat. Section 6. Echoes of the Past. The Carrington event and other solar storms. In 1859, the most powerful solar storm ever recorded, known as the Carrington event, struck Earth. This massive geomagnetic storm was named after British astronomer Richard Carrington, who first observed the solar flare that caused it. The storm's impact was felt worldwide, disrupting the nascent telegraph systems that were the backbone of 19th century communication. Telegraph systems, the internet of their time, failed globally. The storm induced electric currents in telegraph lines, causing widespread chaos. Messages were delayed and communication between cities and countries was severely hampered. Operators received electric shocks and telegraph paper spontaneously caught fire. The intensity of the storm was such that some telegraph systems continued to operate even after being disconnected from their power supplies, purely on the geomagnetic energy. Aurora borealis, usually confined to high latitudes, were visible as far south as Cuba and Hawaii. These spectacular light displays were a direct result of the solar particles interacting with Earth's atmosphere, creating a visual spectacle that was both awe-inspiring and alarming. While technology was less sophisticated then, the Carrington event serves as a stark reminder of the sun's potential to disrupt our lives. Today, our reliance on technology is far greater, making us even more vulnerable to such solar storms. Satellites, power grids, and communication networks could all be severely affected. More recent events, like the 1989 Quebec blackout, underscore our continuing vulnerability to these solar outbursts. That storm left millions without power for hours, highlighting the need for better preparedness and understanding of space weather. As we continue to advance technologically, the lessons from the Carrington event and other solar storms become increasingly relevant. Section 7. The economic fallout when technology fails. The economic impact of a major solar storm could be catastrophic. Disruptions to power grids, communication networks, and transportation systems would have cascading effects across industries. Financial markets could be thrown into turmoil and supply chains disrupted. Estimates suggest that a Carrington-level event today could cost the global economy trillions of dollars. The potential for widespread economic hardship and social unrest is a compelling reason to take this threat seriously. Section 8. Shielding our world. Mitigation and research efforts. Scientists and engineers are working diligently to develop strategies to protect our technology from solar storms. This includes hardening satellites against radiation, designing more resilient power grids, and developing early warning systems. By studying the sun and understanding the processes behind these powerful events, we can better predict and prepare for their impacts. International collaboration is crucial to sharing knowledge and coordinating mitigation efforts. Section 9. A hopeful future. Innovation and preparedness. While the threat from solar storms is real, there is hope. Through scientific advancement and technological innovation, we can mitigate the risks. Early warning systems can give us time to prepare, and resilient infrastructure can withstand the impact. By understanding the sun, our explosive star, we can harness its power while safeguarding our technological world. Let's embrace innovation and preparedness to ensure a bright future for humanity. Don't forget to subscribe to this channel for more insightful explorations of the cosmos and the wonders of science.